David, and I guess there's been a bunch of other contributors to LIO, which stands for Label IO, but I think we're just going to call it LIO from now on because it's simpler. Okay, so building secure systems is super hard. I mean, just building systems, as I think Amit showed, there was nothing security there, was hard on its own, but like, if we look at like what's been happening the past couple of months, Heartbleed and like, GoToFail are kind of SSL related bugs, and like these guys have showed us that actually building anything with security is super hard. So we're at Haskell Symposium, so we're going to use Safe Haskell, like Amit showed, and address a lot of these issues, right? Except kind of like everybody's been showing you to install their code. So please Cabal install my cool library, and you know I am jet lagged, so I just might. And I'm going to use your super cool library to render a PDF from some text file. And sorry about that. And it just so happens that this thing will actually render whatever I want, but it'll also read my pictures and send them to 4chan. I think you might not want to see that. Okay, so you might say, that's fine, but I actually don't really execute untrusted code. I don't execute malicious code, so why are you talking to me? So if you really believe that, I'm here to tell you that you're lying to yourself, because kind of 83% of CVEs are actually application code. So like those SSL bugs are a minority, and in fact, like most bugs are really in applications that we build or others build and we use, so in libraries that you actually might Cabal install. And what I'm trying to get at is basically you should treat your own code as being untrusted, and in doing so, where we now just need to address kind of one problem, and this problem is basically how do we safely execute untrusted code. And the approach that we're taking with LIO is to use information flow control. So the idea behind information flow control, kind of at a high level, is to say associate a security policy with your data. So think of security as policies on data. So like that's something that we've been like talking about the past few days. Like think about the data. So set a policy on this data, and then LIO will actually enforce this policy whenever you're actually trying to perform some, let's say, network request and so forth. So it tracks this security policy throughout the system and enforces it whenever you're about to, like, say, release it. And in associating the policy and tracking it, well, you basically get confidentiality and integrity, right? So you can prevent the 4chan leak. Okay, so let's actually take a look at how we specify policies. In this case, I'm going to show you DC labels, which is one of the things we've been really using to build like, real applications, but LIO can kind of work with, you know, high and low if your data is just high and low. Okay, so a DC label is basically a pair. So can you guys see this, by the way?
Yes.
So, okay, so it's a pair of secrecy and integrity, but because integrity is somewhat confusing and I don't have time, I'm going to talk to you just about secrecy. And the idea of secrecy, so we have a formula, and this formula is in CNF form, and it's basically just a formula on principles. So in this case, I have, say, 4 different labels. The first one is the label denoting public information. So I'm just taking true and converting this to a CNF formula. The second one is data sensitive to Alice. So again, I'm just using strings. The string denotes the Alice principle, and what this is basically saying is Alice is the one who should be allowed to read this information. And we have, say, Bob. So again, because we're using strings, we can actually even use URLs and so forth. So Bob's information here, like it actually connotes to Bob's personal server. So when we have an HTTP library, it will know like who this is talking to. And finally, we have iCloud, something that might actually, like Alice might want to let her data flow to. Okay, so those are super simple ones. The more complicated ones, again, because a CNF is a label like this, so Alice or IC, and this is basically saying that either Alice or iCloud can actually read this piece of information. While Alice and Bob, this is saying that you actually need the authority of both Alice and Bob to be able to look at this information. So like being either Alice or Bob is not enough. So this is sensitive to both. Okay, do interrupt me if things are not clear. Okay, so how do we actually, so that's a label. You set this label on some data. How do we, what does LIO do to actually like make sure that the right information is going to the right place? So you have to basically implement this can-flow-to function, and basically this is kind of what you would expect. So it's checking if a piece of information labeled say A can flow to a destination labeled B. So in this case, we have, say, can public flow to Alice? What do you guys guess? Is this okay or not? So information that is public, can it flow to an entity that is owned by Alice?
Yes.
Yes, all right. What about Alice's information? Can we just send it to a public channel?
No.
Thank you. And what about Alice to 4chan?
No.
Oh, that was like, maybe, huh? So, yeah, the soft no was a no. What about something that Alice or iCloud, information that either Alice or iCloud can actually look at? Is this okay to send to iCloud?
Yes.
Yes, exactly. So, I'm not going to run this. I hope you could. Well, I'll just run it. Why not? So, example, I can't type. Example 1. So, all true. Very good. So, super simple. We now know how to check if we're allowing flows. What happens when we actually combine information? So sometimes we might actually want to take your photos and maybe your photos on 4chan and combine them to do some weird filtering, but maybe not. Okay, so you can actually imagine like two people working together to combine a more sensitive document. In this case, we need to assign that thing some label, and we're going to use lattices. So a DC label just forms a lattice. So the simplest thing is if we have, say, Alice's information, and here love is the thing that is used to do the join of these two labels. So when we combine Alice's and Bob's data, we take the love of it. So and we're going to label, like, let's say this entity Alice love Bob. So if we have some data labeled Alice, can this flow to something labeled Alice join Bob?
Do we read this as and or?
Aha, that is a very good question. So it's just a join, so I'm not going to tell you yet if it's and or.
Well, then we can't say the answer to
Fair enough. All right, so let's answer this part first. So Alice joined Bob. So we're saying that this information is sensitive to both Alice and Bob, right? So if we said, say, Alice or Bob, is this right?
No.
It's not, right? Because this is saying that you can be Alice or Bob to read this information, as opposed to you need the authority of both Alice and Bob. So it's sensitive to both. We're combining both of their informations, and we want to make sure that both of their privacy is actually preserved, as opposed to saying, okay, I'm taking Alice and Bob's data, and now, well, Alice can just say, here you go, read this information.
So and and love are the same?
Yes.
Okay.
That is right. Is that clear to everybody else?
Why didn't you say and or?
Because that might change depending on the lattice you use, but you're right. So and is the correct thing here. So now can Alice flow to the join of Alice and Bob?
Yeah.
Exactly. And what about the reverse?
No.
Yeah, exactly not, right? So we might be leaking Bob's data into something that only Alice is allowed to read. So, false. All right. So example 2. So we got this right also. So I'm not sure how much time I actually have, but I will actually show you, if there's enough time, of how do we actually encode authority. So what do I mean by, like, you need to be Alice or Bob to actually look at this information? But let's, for now, look at a little bit of LIO. Okay, so we know how to set labels. We kind of know how what happens when you join labels. And what we really want now is to label our photos and make sure that now when we do, say, send file, perform some kind of check, like is data labeled Alice allowed to flow to something labeled bob.4chan.com. So we want to make sure that this is actually not allowed. And this is what LIO does. It performs those checks internally and makes sure that the only allowed flows are, only safe flows are allowed. Okay, so what is LIO? Instead of just showing you how to use it, I'm going to show you how we actually build it. So we're using monads to basically define a secure subset of safe Haskell, right? So what we're doing is we want to associate a label with the current computation, and all this label does is it reflects the sensitivity of whatever we've read. So if we've read Alice's data, it better be reflected in this label that we've read as information. If we've also read Bob's data, we want to know that this label is Alice and Bob. So it kind of accumulates taint of reflecting what you read, and as a result, we also want to use this to restrict where you can write. So if you've only read Alice's data, where can you write this? And this should be performed internally by the monad. Okay, so how do we define this? Well, we're just going to wrap the IO monad, and we're going to have an IO ref that's basically going to keep track of the label as a global variable. Importantly, where we actually do use save Haskell is to enforce abstraction. Right? So if we export the LIO TCB constructor, then we're totally screwed. Like somebody can just take and kind of bind an IO action. So we don't want that. We want to execute all our untrusted code in this LIO monad that we know is totally safe. Okay, so what are some things that this monad exports? Well, first we want to get at what the current label of this computation is. So all we're doing is reading the label from the IORF. And we might want to also say, to set this label, but we can only set it to something more sensitive because, again, this label reflects the sensitivity of the information that we've read. So we can raise the label, and we do so by taking the current label and taking it joined to whatever we're about to read. So this is what L is. Is that clear? All right. But how do we actually execute any code? So we want to take some untrusted LIO action, and at the end of the day, we want to produce something. So we're going to basically create an initial kind of state, and the state is going to start in public. Then we're going to actually perform the action, so we're going to execute it, and finally read like the end result and reply back, kind of, well, produce an action that gives you neither, hey, something happened, we have an exception, or the result, and we also have the end kind of label reflecting like the sensitivity of the information that this computation has read. And finally, because I'm going to show you some other things here, IOTCB is, again, anything labeled with TCB is not trusted, so this better not be exported by this module. But internally, we want to use it to actually do something useful. So we want to lift an IO action into the LIO monad. But again, if this escapes the module, untrusted code can use this and now bind an arbitrary IO action that leaks your photos. Okay, and I'm hiding here the instance for monad and functor and so forth because they actually don't do anything. So importantly, like we don't enforce anything in the return to bind or anything else. Everything is enforced in the actual like language primitives, if you will. So we're using the monad to create the sublanguage, and we're going to give you the actual primitives of the language. Okay, let's see. So real apps actually do need to release some information. So we are going to use privileges. If I have time at the end, I'll like actually show you how to use privileges. But the basic idea is where we're going to say, in this case, have a DC privilege, and in this case, we're going to want to say allow and use Alice's privilege. So she can dictate basically if this information should be sent to iCloud or not. So if we have Alice's privilege, we should allow this information to be sent to iCloud. Okay. But let me actually show you how we'd actually implement something like send files or read files. So let's implement labeled IORFs. Okay, so again, we're going to define LIORF, and this has a constructor, LIORF TCB, which has a label and the underlying IORF. And all we care about is, again, since the current label reflects the sensitivity of all the data in the context, when we say performer write LIORF, we're writing to this LIORF. So we want to make sure that the current label, which is LCUR here, can actually flow to the label of the destination that we're writing to. And if this is okay, well, then we're actually going to perform the send, right? So we're writing to something that's potentially more sensitive. But if that's not okay, well, let's just actually crap out and throw an exception. Is that clear? Okay. What about reading? So reading kind of does the opposite, right? So we have some LIORF we want to read from. What do we do? Well, first, what we need to do is make sure that the current label reflects the sensitivity of the information we're about to incorporate into our context. So we're going to raise the label to the label of the reference, which is the join of the current label and this label, and we're going to just perform the read. So it's super straightforward. There's nothing simple, and you can imagine wrapping, say, all the file system, all the HTTP libraries in the same way. So you have some label of an object, and now your functions perform all the checks necessary. So this is where we actually enforce IFC. Okay, 1 minute. All right. So what have we actually like ported, and like we're pitching LIO as a general system. So if you want to use it to build like a secure systems, well, you should just use it in place of IO. So we've ported IORFs, chans, MVARs, and so forth to their labeled equivalent, and the API is pretty much like one-to-one, except you might need to like say what the label of the object that you're creating is. We also have threads, exceptions, file system, database system, HTTP server, and so forth. So you can really build real applications, and we've actually done that. So if you have something that at some point you think will require some security concerns, well, we urge you to port it over. Okay, so I've said you set the labels, LIO enforces information flow control, and kind of DC labels is a pretty simple model and lets you kind of reason about security at a pretty straightforward way, but kind of you still need to set the right policy, and like at the end of the day for complex applications, this can be pretty hard. So like setting the right labels is still, I think, kind of an open problem and something that we're working on. And in the context of web apps, we know kind of what to do, but unfortunately, I haven't enough time to go into that. So bug me afterwards. Okay, so with that, I think I'm just going to point out we did build like a bunch of real systems. Some of them are up and running. Others you can just download and install yourself and give it a shot. So definitely be chat like and install it. So thanks.
We have time for one question.
Hi, this is John Wigley from BAE Systems. In the paper by Yi and Zdanzovic, when they use arrows to do their flow control, one of the benefits they gain from that is they know the join of all the labels of the action before they attempt to execute. So you will never execute a single effect from an action that would result in a policy violation. So since you're using a monad here, how do you prevent that from happening?
So we don't need to worry about landing violations because basically whenever you're about to violate information flow control, right? So whenever you're about to write to, say, a reference that is below your current label, which might be elite, we just throw an exception. And because we have kind of support for exceptions and threads and so forth, we can actually prove the same, well, actually even more.
Even before the action
they
begins executing?
Sorry?
Even before the action begins executing?
No, but you can just use exceptions and say like, hey, I might have done something naughty, let me actually step back and do something else, right? So in the same way we write normal code, I guess.
Thank you.
Let's thank the speaker again.